Welcome everyone. I'm excited to kick off our presentation on mathematics concepts, trigonometry. Today, we'll explore the fundamental ideas behind trigonometry, including key functions and applications. We'll see how trigonometry helps us understand angles, shapes, and even real-world problems. Let's get started and delve into this fascinating topic. Thank you so much for being with me throughout this journey. On this final slide, I just want to take a moment to thank you all for your attention and engagement. I hope this presentation has helped you understand the fascinating world of trigonometry and its many applications. Remember, these concepts are not just abstract ideas. They have real-world relevance and can be incredibly useful in various fields. Once again, thank you for your time and interest. I look forward to exploring more mathematical adventures with you in the future. Trigonometry actually comes from two Greek words, trigonon, which means three angles, and metron, meaning measure. So it's all about measuring angles, specifically in triangles. When we talk about trigonometry, we're focusing mainly on triangles that lie flat on a plane, especially those with one right angle. That's why right triangles are so central to understanding it. The core idea is how the sides and angles of these triangles relate to each other. We use what are called trigonometric functions, like sine, cosine, and tangent, to describe these relationships mathematically. And of course, these functions help us perform calculations that are essential in various fields, from engineering to astronomy. So essentially, trigonometry provides us with the tools to analyze and solve problems involving the angles and sides of triangles, which is fundamental to understanding many aspects of the physical world. The origins of trigonometry can be traced back to some of the earliest civilizations in human history, including ancient Egypt, Mesopotamia, and the Indus Valley, more than 4,000 years ago. It's fascinating to see how these ancient societies laid the groundwork for what would become a fundamental branch of mathematics. Some experts believe that trigonometry was originally developed to help calculate sundials, which were essential for telling time before mechanical clocks. The first recorded use of trigonometry, however, comes from the Hellenistic mathematician circa around 150 BC. Over time, many other mathematicians made significant contributions, including Aryabhata from India, Ibn Yunus from the Islamic world, and Al-Kashi. Their work helped shape the trigonometric concepts we study today. All of these historical developments highlight how trigonometry evolved across different cultures, connecting to our overall theme of mathematical progress and discovery. Let's take a closer look at the key components of a right-angled triangle. As you can see here, OB and AC are labeled as the base and the altitude, respectively. The hypotenuse is the side opposite the right angle, which in this case is the side AC. Now, what makes a triangle a right-angled triangle is the presence of that 90-degree angle. The side opposite this angle, the hypotenuse, is always the longest side. The other two sides, which are adjacent to the right angle, are called the legs or sometimes referred to as the base and the altitude. Understanding these parts is essential because they form the foundation for many geometric concepts we'll explore later. So, keep in mind that recognizing the hypotenuse and the legs helps us analyze and solve problems involving right triangles more effectively. Let's take a closer look at this important relationship in right triangles. The equation AC2 equals OB2 plus BC2. This means that in any right triangle, if you construct squares on each of the sides, the area of the square on the hypotenuse, which is the side opposite the right angle, is exactly equal to the sum of the areas of the squares on the other two sides. In the figure, you can see how the square on side AC, the hypotenuse, relates to the other two. This is the core idea behind the Pythagorean theorem, which is fundamental in geometry. It helps us understand how the lengths of the sides of a right triangle are interconnected. This theorem not only broadens our understanding of triangles, but also connects to many real-world applications, from construction to navigation. So remember, whenever you're dealing with right triangles, this relationship is a powerful tool to have in your mathematical toolkit. Now let's take a closer look at the key ratios in trigonometry. First, we have the cotangent, which is the ratio of the adjacent side to the opposite side. Think of it as the reciprocal of tangent. Next, there's cosecant, which is the hypotenuse divided by the opposite side, essentially the reciprocal of sine. Moving on, we have cosine, which compares the adjacent side to the hypotenuse. Secant is similar to cosine, but as its reciprocal, hypotenuse over adjacent side. Then there's tangent, which is the opposite side divided by the adjacent side, a fundamental ratio in right triangles. And finally, sine, which is the opposite side over the hypotenuse. These ratios form the core of trigonometry and help us analyze angles and sides in right triangles. They're essential tools that connect angles to side lengths in a very elegant way. Now, let's look at some important trigonometric ratios involving angle C first. Cot theta is equal to AC divided by OB. This ratio helps us understand how the adjacent side relates to the opposite side at angle C next. Cosec theta is also AC over OB, which is the reciprocal of sin theta. Moving on, sec theta is equal to AC over BC, giving us a measure of the hypotenuse over the adjacent side. For cos theta, it's BC over AC, which is the adjacent over hypotenuse. Then, tan theta is OB over BC, representing the opposite over adjacent. Finally, sin theta is OB over AC, which is the opposite over hypotenuse ratio. These ratios are fundamental because they allow us to find unknown sides or angles in right triangles, especially when angle C is involved. Recognizing these relationships helps us connect the different aspects of the triangle and solve various problems efficiently. Let's talk about the value of trigonometric functions. These functions, sine, cosine, tangent, are incredibly powerful tools in mathematics. They help us understand and analyze angles and their relationships in triangles and circles. The key point here is that they allow us to model real-world phenomena like waves, oscillations, and rotations. For example, sine and cosine functions describe periodic behaviors, which are everywhere, from sound waves to light waves. And tangent helps us find ratios of sides in right triangles, giving us a deeper understanding of angles. Overall, these functions are essential because they connect geometry with algebra and calculus, enabling us to solve complex problems across many fields. Their value truly lies in their versatility and the way they help us interpret the world mathematically. The main use of trigonometry is in construction, where it helps in designing and building structures accurately. But its applications go far beyond that. This field of mathematics can also be applied in astronomy, helping us understand celestial movements and distances. It's essential in navigation, aiding in determining positions and plotting courses. Trigonometry plays a vital role in acoustics, improving sound quality and designing auditoriums. It's used extensively in medical imaging, like ultrasound technology. Civil engineering relies on it for designing bridges, roads, and buildings, ensuring safety and precision. Seismology uses trigonometry to analyze earthquake waves and Earth's interior. Electrical engineering applies it in circuit design and signal processing. In phonetics, it helps analyze sound waves and speech patterns. Chemistry benefits from trigonometric principles in molecular modeling. Number theory, although more abstract, also connects through mathematical concepts involving angles and ratios. As you can see, trigonometry's impact is widespread, touching many fields, and it's a fundamental tool in solving real-world problems across various disciplines. Now, let's explore some real-life applications of trigonometry. You might be surprised to learn how often we use it outside of the classroom. For example, in architecture, trigonometry helps engineers design structures that are both safe and aesthetically pleasing by calculating angles and forces. In navigation, pilots and sailors rely on it to determine their position and chart courses across vast distances. It's also crucial in fields like astronomy, where it helps measure distances to stars and planets. Additionally, in the medical field, trigonometry is used in imaging techniques such as CT scans to reconstruct 3D images of the body. These examples highlight how trigonometry isn't just theoretical. It's a powerful tool that impacts many aspects of our daily lives and various industries. This connection between math and the real world underscores the importance of understanding these concepts thoroughly. Trigonometry is a branch of mathematics with several important and useful applications. Hence, it attracts more and more research with several theories published year after year. This continuous research highlights how vital trigonometry is across various fields. It's not just about angles and triangles. It's about solving real-world problems in engineering, physics, and even computer science. Understanding the key concepts of trigonometry allows us to approach complex problems with confidence. And as we've seen throughout this presentation, its principles are fundamental to many scientific and technological advancements. So, in conclusion, trigonometry is both a fascinating and practical area of mathematics that keeps evolving. Its applications are ever expanding, making it a crucial subject for further exploration and study.